Okay, I think we're live. Okay, so you guys really, please do the review. Please just take the time to do the review. Okay, so first of all, tell whether it's direct, inverse, or neither. So if it's direct, it's going to be some y equals some kx plus 0. The 0 is important, okay? It's got to go through the origin. Inverse variation, some x, y equals some number, and neither doesn't match up at all. So number 1 is definitely got to be inverse. X, y equals some number, so this one's definitely going to be inverse. Okay, number 2, well, it's this plus 3 that messes it up, so let's go through 0, so it's neither. And y equals 1/2 x matches up really well to that one, which makes it going to be direct. Okay, now let me keep going with this. Now number 4, if I graph it, it might help. So if I take a look at a graph, and I remember what these look like. Hold on, let's see. I've got a 2, 1. I've got a 4, 2. 1, 2, 3, 4, 5, 6, 7, 8, 3. Oh, it's starting to curve, darn it. So it looks more like it's going to curve, and if it curves, it's neither. It's neither. Okay. 5. Well, 1 times negative 8 is negative 8. 2 times negative 4 is negative 8. 4 times negative 2 is negative 8. 1 times negative 1 is negative 8. So it's x, y equals negative 8. So that one's going to be my inverse. Okay. All right, moving on. 6. The variables x and y vary inversely, and y equals negative 3 when x equals 5. So inversely, I'm going to go x, y equals some k value. But obviously, k's got to be negative 15, because if I plug in 5 and negative 3, k is going to be just negative 15. Okay, so here's my equation. X, y equals negative 15. Okay, that's my equation. I need that. And the next piece of this is if find y when x is negative 4, so I'm going to plug in negative 4 for x times my y equals negative 15. If I divide by negative 4, what is that? 15 fourths, that's like 3 3/4, I think? Probably, yeah, 3.75. Okay, so I get y to equal positive 3.75. There we go. Okay. All right, 7. I'm going to need extra paper to do these because these take some time. So on 7, first thing I see on 7 is they'll factor. So I'm going to factor, okay? So I'm going to factor in 7. I'm going to get an x, common factor out an x plus 5, and the denominator, oh, let me get a pen that works. God, my pens are getting old, getting tired. All right, let's see what I get. I'll get a x plus 5, x plus 5, right? Kind of sloppy. I'll try and make it neater for you guys. Just need a better pen. Okay, nope, that's not going to work. Okay, so then x plus 5's cancel. I'm just left with an x over an x plus 5. That's it, okay? Number 8, I'm going to just start reducing. Let's see. 5 of these will cancel with 5 of these, and I'll just be left with an x squared. 1 of these will cancel 1 of these. Y cubed. 12 and 8, let's see, I can reduce these both by 4, so I'll have a 3 and a 2, and let's see, 4 and 6, I'll reduce these both by 2, I'll have a 3 and a 2. Oh, wait, see, it's 3 and 3, I can cancel that and that. Let's see, what's left on top? Just a 2, and on the bottom I still have this 2. Oh, those will cancel too, won't they? And then I'll be left with just a 1 over an x squared y cubed. Okay, cancel as much as I can. 9. Okay, let's do 9 over here. So first of all, I'm going to factor. So let's see, I can factor out a 2x of an x plus 1. I can factor out an x of an x minus 3. There's a 1. I can factor this into an x minus 3, x plus 2, and I can factor this into 1 and 1, right? X plus 1. X plus 1. Let's see. Cancel. X minus 3 is x minus 3, right? Oh, I got an x with an x. Cancel that with that. X plus 1 with an x plus 1. And that seems to be all I have. So I'm going to put the answer over here. Squeeze over. See, I have a 2. And I have an x plus 2 over an x plus 1. Okay, there we go. 10. I've got to flip it first. So let's rewrite this. I've got my 5x squared y, 7y to the second, but then I'm going to flip this, flip it, right? Flip the second one, always flip it. So I'm going to flip this one, and I'll have a 35y cubed over a 15x squared. Now I'm going to cancel, 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 cancel. Right? 5 and 15, I can go 1 and a 3, right? 735, I'm going to reduce that by 5, so I have a 1 and a 5, right? X squared, oh, these x squareds cancel completely. See, x squared, boom, x squared, y cubed, y, I can take 1y out of that one, and I have 1y left over, and let's see what I have left. Well, in the numerator, I've got a 5y, and my denominator just a 3. Hey, I like the way that worked, okay? 12, okay, so let's take a look at 12. I already have a common denominator. Common denominator is just a 2x plus 1 in my numerator. Let's see, I got to be careful with the subtract. Be super careful with the subtract. Super duper careful with the subtract, so I'm going to have a x minus x gone. A negative 3 minus 9 makes a negative 12. That's it, okay, boom. Be careful with 13. I think there's a trick in 13. Be careful. Common denominator, yes. X plus 2. And then I can add. I'm going to have a 6x plus 12. And then, believe it or not, this will factor. That's where you've got to be careful, okay? Factor, okay? You'll miss half a point if you don't simplify. Take out a 6 of an x plus 2. And what do you know? X plus 2. Cancel, cancel. And I'll have an answer of 6. Okay, I know I'm going kind of fast, but you guys can always pause it and watch it. Okay, now, 14, a little bit harder. Okay, 14. What I'm going to do first is factor this one. Okay, common denominator, x plus 3x plus 2. So let me rewrite this so you can see what I'm doing here. I'm going to have a x squared plus 2x over, okay, x plus 3 x plus 2, okay, and on the second fraction, 1 over x plus 3. Now I need to get a common denominator because I'm adding or subtracting. Common denominator. So this second fraction needs an x plus 2. Let's give it an x plus 2. Okay, and then let's see what I have. So my common denominator is my x plus 3, x plus 2, and then my numerator, let's see, I'll have an x squared plus 2x, and I gotta be careful of the minus, be careful of my minus, be careful of my minus, so I'll have a minus 1x, and be careful of the minus 2. Okay, let's simplify this. Let's see what I have. Okay, so my denominator, x plus 3, x plus 2. My numerator, x squared plus 1x minus 2. Oh, I think I can factor this. I think this will factor. I think that'll factor. It might make a difference. I think so. So let's see if I factor this one. I think it's going to be a 2 and a 1. X plus 2, right? And x minus 1 makes my negative 2 and adds to my positive 1. And that's kind of cool because look at this. And I can cancel. Cancel. And left just with left an x minus 1. Or an x plus 3. Boom. Okay, I like that problem. That's a good problem. Okay, turn the page. Okay, we're almost there. On number 15, I'm just going to cross multiply. Okay, cross multiply this times this. Cross multiply. Okay, so we talked about yesterday. So I'm going to have a negative 1. I'm going to multiply those two equals an x times an x plus 2. Okay, which is a negative 1 equals a x squared plus a 2x. I can bring over this negative 1. I'm going to add the negative 1 and put it right there. So I'm going to have a 0 equals an x squared plus a 2x plus 1. I think I can factor that. Yes, indeed, I can factor that into an x plus 1, x plus 1. And then with my mini equations, we get x equals negative 1. Is that okay? Yes, that's okay. We just can't have a 0, and we're done. Okay. Number 16, I might need to do on a separate sheet here, but I can do that. Okay. 16. Let's see. I'm going to need a common denominator, so I'm going to multiply this one by a 3 over a 3. Multiply this one by an x plus 2, x plus 2, and this one by a 3 over 3. Let's see what happens in 16. So my denominator is going to be 3 times my x plus 2, sorry, my bad. It's my common denominator. And over here, my common denominator is going to be a 3 times x plus 2. Okay, that's my common denominator. Now, my numerator is going to be a negative 6x plus, let's see, I'm going to have a x squared plus 2x, right? And over here, I'll have a 12. Well, we've learned that once you get the common denominator, you multiply both sides by that common denominator. Just scribble it out, because multiply both sides by 3 times x plus 2, 3 times x plus 2, boom. Now let's see what we have. We'll have a x squared plus a 4x equals a 12. It looks like we might have to factor, so I'm going to bring the 12 and put it right there. So I'm going to subtract my 12, and I'm going to get my x squared plus my 4x minus my 12 equals 0. Factor. How about 6 and 2? Plus 6x minus 2 equals 0, right? Because that'll make the 4 and the negative 12. So I get two answers, x equals negative 6 and x equals 2. But wait. Never mind, that'll work. I thought the negative 2 wouldn't work, but it can. Just can't have a negative 2. Okay, cool. Those two answers. I can live with that. Okay, now number 17. Find the following. So if I have to graph this, one of the things I want to do on 17 is, first of all, I am going to factor. And then if I take a look at my multiples, I'm going to have a positive 5, and I can have a negative 2, okay, because that'll make the 3 and the 10. So first of all, right off the bat, x cannot equal negative 5, and x cannot equal 2. So if I put this on Desmos, or in my case, I'm just going to use my graphics calculator. You guys can use Desmos, I suppose. That's all we're doing. And I go y equals, and clear that, and if I go my parentheses, my x plus 5, x plus 5 divided by parentheses, my x squared plus my 3x, subtract 10, check my window, yeah, it'll work, graph. And I get some weird stuff happening at 2. Well, that makes sense. There's my asymptote. So my vertical asymptote, and I need graph paper here. My vertical asymptote I can see it. I can see my vertical asymptotes at 2. X cannot equal 2. So it's going to be simply at x equals 2. That's my vertical asymptote. Okay. There's a thing called the hole. We haven't talked about the hole yet, but the hole's at negative 5. So my hole's at negative 5. We'll talk about that more in class. My hole's at x equals negative 5. Now, if I have to graph this, it looks a lot like this. Okay, so, and again, I'm using my calculator to do a lot of the work for you, but I have to have this asymptote at 2. Okay, vertical asymptote at 2. Have to have that. Looks like the graph looks like this. Okay, kind of like I thought it would look like. Okay, so if I graph it in like this, does not touch, right? And like this, does not touch. Okay, and then domain. Well, the domain's everything except for these two. Okay, the domain's got to be x equals all real numbers except x cannot equal negative 5 and x cannot equal 2. Okay, almost done. 11. Beth. So this is a work problem. So we're going to have a work problem is Beth can tile one floor in 10 hours by herself. So she can do one job in 10 hours. But if she works with Tom, they can tile it in 5.8 hours. Okay, now we don't know Tom's rate. So Tom can do the one job in X amount of hours. Okay, now if they do it together, we know it's going to take 5.8 hours. So I'm going to put the 5.8 here. So 5.8. So Beth can do her portion, 5.8 out of 10. Tom can do his portion, 5.8 out of who knows how fast Tom can do it, to get the one job done. Okay, now at this point in time, what I'm going to do is just get a common denominator. Okay, so I'll multiply this one by x over x, and this one by 10 over 10, so that my common denominator between these two fractions is a 10x. Okay, then what's on the numerator is a 5.8x plus a 58 equals 1. Okay, now let's solve. I'll cross multiply, I'll bring multiply up to 10, and I'll have a 5.8x plus 58 equals 10x. So I got to solve for x. Minus 5.8x minus 5.8x. I've got a 58 equals, I don't know, well, 4.2 would probably do. Yeah, 4.2x. And then divide 58 by 4.2. Let's see what I get. 58 divided by 4.2. And I get an answer of about 13.8. So Tom isn't as fast as Beth. It's going to take Tom 13.8 hours to tile the floor, okay? And that's all I have. Hopefully you guys will be fine on this.